Replacing NumPy array entries with their frequencies, values from dictionary. Problem: from two input arrays, I want to output an array with the frequency of true values, from input_2, corresponding to each value of input_1. For this example, output that I want is. My current approach involves editing input_1, so only the values corresponding to true remain. Then counting the frequency of each answer, creating a dictionary and replacing the appropriate keys of input_1 to values, the true frequencies. Which outputs 3, 2, 2, 3, 2, 1. The problem here is twofold. 1. This still does not do anything with the keys that are not in the dictionary, and should therefore be changed to 0. For example, how can I get the 3's transformed into 0's? 2. This seems very inelegant, ineffective. Is there a better way to approach this?
np.binCount is what you are looking for.
And the next solution is correct, +1. However, it will be very slow and take a lot of memory if the values in input_1 are really large, i.e. they are not indices of an array, but say they are seconds or some other integer data that can take very large values. In that case, you have that np.binCount input_1 input_2. Dot size is equal to the largest integer in input_1 with a true value in input_2. It is much faster to use unique in binCount. We use the first to extract the indices of the unique elements of input_1, and then use binCount to count how often these indices appear in that same array, and weigh them 1 or 0 based on the value of the array input_2, true or false. This solution is really fast and has the minimum memory impact. Credit goes to @Jamie, see his comment below. Below I report my original answer, using unique in a different manner. Other possibility. It may be faster to go for another solution, using unique. This has the drawback that it will require a lot of memory if the number of unique elements in input_1 with a true value in input_2 are many, because of the 2D array created and passed to where. To reduce the memory footprint, you could use a for loop instead for the second step of the algorithm. This second solution has a very small memory footprint, but requires a for loop. It depends on your typical data input size and values which solution will be best.
The currently accepted binCount solution is quite elegant, but the NumPy_index package provides more general solutions to problems of this kind.
If you want to see more, please consider subscribing.